Good morning, scientists. So today we've got big fun. We actually got a lab for you to do. So the first thing that I want to let you know is right now, if you need any extra credit, this is like your last opportunity. One of the modules I have is the extra credit mods, which is the Museum of Discovery and Science extra credit. There are several different labs there that you could have done. I know I had probably about a dozen students do those little lab activities at home and submit them little lab reports for some extra credit. If you need some extra credit and you're looking for that, maybe this weekend, over the long weekend or something, maybe work on one of those. If you have any questions or want to know how to do that or need some advice, let me know. I'll help you out with that. So that'd be due probably, Friday of next week, so on the 29th. So today, first thing, one of the links that you'll see there is something just kind of silly. It's the NASA Johnson style music video. Well, the NASA Johnson Space Center in Houston, Texas, that's the NASA headquarters. And so that's where all the astronauts, they do their training, all the administration is there, scientists do work there. Astronauts will train there, then they go to Florida and to actually launch, or to Russia to launch into space. Also, don't forget, I'm going to remind you later too, but on the 27th, 2 astronauts are going to be launching from Cape Canaveral for the first time since 2011, so since the last space shuttle went up. So that's something to look forward to. So speaking of launching rockets, that's what our lab's all about. So you can watch that music video. It was actually created by some interns that were working there a few years back, and they actually got astronauts, scientists, administrators, a whole bunch of people to take part in that. It's kind of fun, you know, something to check out. So for today's lab, you're actually going to build a rocket. So you're going to build a little straw rocket, something like this right here. And this is one of my favorite labs we usually do in the classroom. And I do it a little different in the classroom with different kind of materials. We control the variables a lot better. But since I can't send all that equipment home with you, we're going to do it kind of on the kind of a little easy simplified version. So for the first thing is look at the link that I have on the module. There's a NASA link that has pretty much the lab report, the data table, all the instructions right there. You could download it. I made it a Word document so you can even type on it, edit it, do whatever you want. And then there's also a little NASA video where the woman, she kind of coaches you through kind of how to do it. Watch that video. You might say, oh, I got this, I'm gonna do it. Watch the video anyhow. It'll make it a lot easier. It'll save you from making mistakes. And then the next thing is it asks you to print out something and then cut that paper out to make your rocket. Even if you don't have a printer and you can't print it out, just use a regular old sheet of paper and you could cut it pretty close to what they have it. You can kind of estimate. It doesn't have to be perfect, all right? So each person's rocket's gonna be a little different, and that's fine. So then you're gonna go ahead and build your paper rocket, and you're gonna wrap the paper around a pencil, something like this. So whoop, so there's the pencil. So I took a piece of paper, wrapped it around here, taped it together, made a nose cone, and made some fins, stuck them on there. Your fins could be any shape you like. And then you're gonna take a picture of what your rocket starts out like so that you'll have a picture of your rocket at the beginning. So your beginning rocket, that'll be your first picture. And save that picture, you're gonna need that at the end. And then you're gonna go ahead and do your tests, just like we used to do in class, where you do an experiment. You do several trials. So you launch your rocket, just like this, see how far it goes. Do a few practices, and if you'll notice on the data table, you'll see it has like several trials. So you launch it 3 or 4 times, I forget exactly how many times there are, then you average the distance, and then you figure out the average there. Then you'll go ahead and make a change to the rocket. So first of all, when you do launch it, you'll have it on the straw. You find a straw around the house, or if you get some takeout this weekend or something like that, get a straw somewhere. And so you got your straw there, and then you launch your rocket. So now you've launched your rocket. You'll do that, you measure how far it goes. If you got a tape measure, you could, if you got something that measures in metric, that's awesome. If you don't, measure in inches and feet, that's fine. I know inches, that's a bad word in science, but you know, that's okay. Use what you got at home, all right? So if you got a yardstick, if you got a tape measure, if you got a meter stick, even better. If you're able to measure in metric, that's fine. So you measure how far it goes. Try to, when you're blowing into the straw to launch your rocket, try to do it the same way, with the same amount of force, at the same angle. So if you're doing it straight parallel with the floor, do it the same way every time. If you're doing it at a 45-degree angle, do it at a 45-degree angle every time. But try to blow with the same amount of force. That's gonna be the hard thing. If you're doing this in the classroom, I have a machine where we drop a weighted rod and it launches it with the same exact amount of force every time. So you're gonna have to figure out a way to control your launch force. That's also why we'll do it several times for each test. So then you take your rocket and you're gonna change something about it. You could change the nose cone, you could change the fins, you could change the length of the rocket, whatever you want, but only change one thing. Because remember, in a good experiment, you only change one variable at a time. So you change that one variable, and then you'll do the experiment again. So make sure you're recording. What did you change? What's the one thing you changed? How far did it go? And so forth. So make sure you're recording that data. Again, if you can't print out the data table, you could do it on the computer. If you're gonna have your data table, make sure you save it in your OneDrive or your Office 365 account. That way you could edit it, do everything on there, and then even if your computer dies or quits on you, you could pull it up on any other computer, your phone, whatever, and you could still submit the work to me. Because how you're gonna get credit for this lab is submitting your data. You're gonna submit that data table, and you're also gonna write down 3 things that you tried to control. What are 3 things you tried to keep the same for every trial, for every test? So and then you have to try to change 8 or more things. Hopefully 10 different things about your rocket. So once you've done your experimenting with your rocket, by the time you finish, your rocket will probably look a lot different. So you'll take another picture of your rocket at the end. I know this is a pencil because my rocket flew way over there somewhere. So you'll take another picture of your rocket. How did the fins change? How's your nose cone different? Take another picture of it, and then you'll send me the picture of your rocket at the beginning, picture of your rocket at the end, and your data. So those are the 3 things you're gonna submit. You submit those 3 things, you get 100%. That is if you did a good job on your data. If you handwrite your data, if you do it on a piece of graph paper or a piece of paper and you did a nice organized graph chart that way, and you take a picture of it and you wanna send that to me, you could do that too. If you scan it, take a picture, send it, that's fine. If you're more comfortable writing it out by hand using paper and pencil, no problem. I gotcha. And let's see, I'm looking at my list. Is there anything else? That's it. Make sure you don't go shooting your paper rockets at your little sister or your dog or something like that. So we don't want to poke anybody's eye out. So make sure you're being safe. Do it in a wide open area, not towards anybody's eyeballs. Otherwise, maybe have them wear safety goggles around. So you're like, hey, you over there, put some safety goggles on. I'm launching rockets over there. So I'm sure you got safety goggles around the house, right? That's not due till Wednesday of next week. So you've got a long time to do it because I figure it'll probably take you a couple days. So it'll probably take you maybe 2-3 hours to complete all that. Building the rocket might take you a little while, then changing it, figuring out, coming up with different ideas. So it's gonna take you a few days. So if you happen to get it all done in one day, maybe you're bored, you got nothing else to do today, and you get it all done and submitted to me today, great. If not, do a little over the weekend, you got Monday, you got Tuesday, make sure it's into me by the end of the day, Wednesday, all right? All right, until next week, stay curious.